All right, let's do a little quiz review in case you missed it or you need to do a retake. Hopefully this will be helpful. So to solve by graphing, ideally we want both of our equations to be the form y equals mx plus b, because from that form, remember m is our slope and b is our y-intercept, or where it crosses the y-axis. So that helps us graph nicely. So the first line is in slope-intercept form, where the slope is negative 1/3 and the y-intercept is negative 5. So I can start at negative 5 on the y-axis, and then negative 1/3 slope is down 1 and to the right 3, or up 1 to the left 3. Remember, slope is rise over run, and negative, I want it to be going downhill from left to right, downhill like that. My next one is not solved for y yet, so I'll have to get this equal to y. So I'm going to isolate the y variable. So I'm going to start by, it's a plus x, I'm going to start by subtracting x to both sides. Let me make this a little bit bigger. So then we end up with 3y equals, I cannot combine the 15 and the x because they are not like terms. So I'm going to have a negative x and a negative 15 still. So I'm going to write that as negative x minus 15. And then divide by 3 to get y by itself. So we're going to get y equals, and negative x divided by 3 is the same thing as negative 1x divided by 3. So I'm going to leave that as just negative 1/3 x, and then negative 15 divided by 3 is negative 5. So graphing this one has a slope of negative 1/3 and a y-intercept of negative 5. So it ends up being actually the same line. So that means that these intersect in all points. So my solution is many solutions. So same line, many solutions. So when you're graphing and solving by graphing linear equations, you're looking for when the lines intersect. So sometimes they'll intersect just in one place, and then that where they intersect, that point would be your solution. In this example specifically, they intersected in all points. All right, graphing a system of inequalities is going to be done fairly similarly. We want to use y equals mx plus b to graph the lines. A couple things we'll need to remember is we're going to make a dashed line anytime we have less than or greater than symbol. That indicates that the points along that line are not solutions to the inequality. And then we're going to graph with a solid line anytime you have a less than or equal to or greater than or equal to. And then for less than or equal to or less than, we're going to be shading below the line. And then for greater than or equal to, we're going to be shading above the line for shading. All right, so our first equation is y plus x less than 8. So the first thing we need to do is solve for y. So I'm going to subtract x to be y is less than negative x plus 8. So now this one has a slope. It's a negative x. It's the same thing as a negative 1x. So this is a slope of negative 1 over 1, y-intercept of 8. It is just less than, and so that means it's going to have a dashed line, and it's less than, so we're going to be shading below that line. So we're starting at positive 8, so straight up from the origin to positive 8 on the y-axis for our y-intercept. Downhill, negative 1, so down 1, left 1, down 1, left 1, or up 1, right 1. And then I want this to be a dashed line. And then the y values, y is less than this line. This is my y-axis. The y values that are below the line then are down here. So we're going to be shading this hemisphere, this half of the graph for that line. All right, then for my next line is 2y minus 4 greater than or equal to negative x. So I need to solve for y, so I need to isolate this y. So the first thing I'm going to do with this minus 4 is add that over. We get 2y greater than or equal to, can't combine those, so it's just negative x plus 4. divide by 2, get y is greater than or equal to, this is negative 1x, so it's negative 1/2 x, and then 4 divided by 2 is 2. So this time I have a slope of negative 1/2. I have a y-intercept of positive 2. It's equal to, greater than or equal to, so the equal to tells me that the points are included in my solution set, so my line will be solid. And it's greater than, so I'm going to be shading above this line. So I'm going to go to the y-axis, and I'm going to start at positive 2. Slope of negative 1 is up 1 to the left 2, up 1 to the left 2, or down 1 to the right. So I want to make sure that I'm going one positive direction and one negative direction for rise over run. And then this is a solid line, and I'm going to be shading above, so the y values that are greater than that line are up here, so we can see that they intersect in this area in between. So I'm going to shade that in between there. All right. This one has a couple special cases. It is y greater than negative 8, x less than or equal to 4, and then y greater than x. So let's see what this looks like. So first we'll start with y greater than negative 8. So if you think of y equals mx plus b, this is a y equals, but we have no x term. That means our slope here is going to be 0. And then our y-intercept is at negative 8. This is just greater than, and so it's dashed, and then all y values that are going to be greater than negative 8 are going to be shaded above there. So we're on the y-axis, go down to negative 8, and then I want a dashed line, and then we should be shading above that one. The next line is x is less than or equal to 4. So this does not fall into the form y equals. It's actually x equals. So this is a special case. This is where it's a horizontal or vertical line, I'm sorry, where our slope is undefined and there is none for a y-intercept. So this ends up being parallel to the y-axis. So at x is positive 4 to the right from the origin, it's going to be a solid line this time because it's equal to. And then if you graph that quick, so you're going to have a vertical line at x equals positive 4. And all the x values that are less than 4 are actually going to be to the left. Like 0 is less than 4. So we're going to shade this one to the left this way. All right, I'll do the last one in green here. And this is y is greater than x. Now y equals x is actually the parent function. So this does fall into the mx plus b form where we have a 1x. So our slope is 1. We have nothing at the end, or a plus 0 would be equivalent. So our y-intercept is 0. It's greater than, not equal to, so we're going to have a dashed line. And then we're going to be shading above because it's greater than. So this one starts right at the origin and has a positive slope of 1. So this is actually the parent function here. It's going to be dashed. And the y values that are greater than this line are going to be the y values up here. Like if you think of y equals 0 right here, then y equals 5, y equals 10 is all greater than 0. So we go towards those y's, which is up here. So if I look at where my orange and my blue and my green intersect, it's right here. Stops at this green line here, and then kind of outlines this way. So that is my answer. All right, I'll do a couple solving ones. So solving using substitution. So this one is not really set up very nicely for substitution, but we'll still solve with substitution since we were asked to. To solve a substitution, we want either to have x equals or a y equals. So I'm going to start by solving one of my equations for x or y. And I think I'm going to pick the last one here. We have 3x plus 3y equals negative 3. I'm going to solve this for y. So I'm going to subtract 3x from both sides. I noticed that they all have 3's, so I thought it'd be an easy one to solve. We get 3y equals, and then I have negative 3x minus 3. Then divide everything by 3 to get y by itself. So we got y equals, and negative 3 divided by 3 will be negative 1x, and negative 3 divided by 3 will be negative 1. So now I can take this negative 1x minus 1 and my other equation, which was negative 3x minus 4y equals 2, and I can substitute this value in for this y here. So I have a y equals, so I'll plug that back in. So negative 3x minus 4 times y, where y is negative 1x minus 1, equals 2. Then we got to distribute and finish solving. So we got negative 3x. Negative 4 times negative 1 is going to be positive 4x. Negative 4 times negative 1 again is going to be positive 4 equals 2. Finish solving for x. I'm going to combine like terms. Negative 3x plus 4x is 1x plus 4 equals 2. Finish solving for x. Subtract 4. And 1x is the same thing as just x. 2 minus 4 is negative 2. So x equals negative 2. I'm not done though. I need x and y, so I'm going to plug that back in over here. We had y equals negative 1 times x. X is negative 2, and then minus 1. It's 2 minus 1, so y equals 1. Final answer would be written as an ordered pair, so parentheses, negative 2, 1. All right, I'll do one more. Solve using elimination. Let's see. Okay, so if I want to, let's say we're going to eliminate the x's. I have a 5 and a 3. The lowest common multiple they have in common is 15. So I'm going to need one of those x's to be positive 15x and one to be negative 15x. So I'm going to take the first equation and I'm going to multiply it by just positive 3. And then that's going to give me 15, or 3 times, it would be negative 15x plus 3y, equals negative 6. Then since I got a negative 15x in the top, I need this one to be a positive 15. So I'm going to multiply the bottom equation by a negative 5. So I'm going to get positive 15x, and then negative 5 times 6 will be negative 30y, equals 12 times 5 is 60, positive 60. Now I can eliminate by adding these two equations together, and we're going to get x, negative 15x plus 15x is 0, so those are eliminated now. So 3y minus 30y, or plus negative 30y, is negative 27y, equals negative 6 plus 60 is going to be 54. Finish solving, divide by negative 27 on both sides. This works out nicely because y, 54 divided by negative 27 is negative 2. Remember that that's not your final answer though. We still need to take that. Let's take the top equation, negative 5x plus y equals negative 2. We need to plug that back in for y and solve for x. So negative 5x plus minus 2, or plus negative 2y, equals negative 2. Finish solving for x. I'm going to get negative 5x equals negative 2 plus 2 is 0. Now if you get to this this case, negative 5x equals 0, that means x has to be 0 because you have to divide by negative 5, and anything 0 divided by any number is 0. So final answer is 0, negative 2. All right. For the sake of time, I am going to stop there.